Were we on? Hang on. There we go. Were we on this one?
The one after.
This one?
We have one after that.
Okay, so we're on the video.
Yeah.
So we are at the video. Oh. Okay, so start off class. You guys get a video. 9 minutes, so starting strong.
It's like 20 minutes off.
Right. Yeah, go ahead and hit the first one. So what this video is going to be explaining is all of the mineral groups. It includes a few more that I don't expect you to remember. So just know that there are more mineral groups, but I don't expect you to know those ones. So it goes over all the ones we are talking about, but it also includes a few more that I do not expect you to memorize. Go for it.
That's what I was going to say, dude. But which one do you want?
Yes, they're doing
All right. Let's start that.
trying to force choke the people. We like the hand.
All right, here we go.
This video, we're going to take a look at it makes sense that also a little bit of and
Which ones are different here? Which ones do we see are different here besides my hand up there? What do we see here, Johnny?
Phosphates.
Phosphates are one of the ones we have not, that I do not expect you to know. Any other ones? Any other ones up there, Aiden?
No.
I don't see any either. I think it's just phosphates. Silicates, yep. Native elements, yep. Carbonates, yep. Halides, oxides, sulfates, sulfides, yep. So only phosphates. There's actually more than that too, but this guy's actually dumbing it down a little bit too. There's a lot more. But which one has the most? Which one has the most amount on Earth, Ian?
Isn't it oxygen?
You're thinking of the element. Which one of these mineral groups? Oxides, no. Blake?
Native elements.
Aiden? Silicates. Silicates.
What makes that? This is together. And it kind of, so you can see
You don't need to know this part, but kind of food for thought.
the most or needed. These are because of that. These are those These are
Dang it. What is a cation? Those of you who are in my class on physical science. So 2 years ago, Ian, do you remember what a cation is?
I immediately think of iron, but no.
Bethy, do you remember what cations are? There. William?
Oh,
Perfect.
I don't know.
I have failed. I have failed.
Positively charged ion.
They are positive. Cations, they are positively charged. Man, that's how you remember them.
We're a little rusty.
That's how they're going to teach you in high school. Okay, sorry about that.
those. How I know.
How I know. These are the only these minerals with varying so the kids there's some was
Oh, I see.
which matters. With the key being so that's and all sorts of other resources over at
What if you put that video? I want to watch more. Those phosphate ones, I have a couple rocks that look just like.
It just
You can look on there. It'll say, if you want to look at more, it'll show you on there.
Those minerals, dude, you eat rocks basically. Yeah, minerals.
So,
So Dwayne Johnson
need
got
iron.
watching some.
Yeah, I don't think I've ever had fun a long time.
we got rocks.
There's salt in the water.
Well, yeah, but like, there's no.
There's
It
salt.
would be Himalayan.
Okay.
salt. Wait, what about Earth?
Where's snacks?
So takeaways from that video. Takeaways from that video right there. Aiden,
There's a lot of different kinds of rocks.
there's a lot of different types of rocks. Yep. There's a lot of different types of rocks. Kayla?
The phosphates are very rare.
They're very rare, and that's usually why we don't, that's one reason I'm not having you guys memorize that one, just because they're so rare. You really don't see them, especially where we're at. You're not gonna really find them.
I think they're silicates. Those are metallic with
Mhm.
sulfur,
Yep.
but not oxygen.
Yep, only with sulfur, not oxygen. William?
When I brought those two rocks,
Mhm.
you showed it.
I have not. We're gonna be later, is it next week? Next week we'll be actually identifying different types of rocks and going out and we'll be doing scavenger hunts. If you want to see what we're gonna be doing in your lab manual, there's 3 different scavenger hunts where we're gonna be going outside and looking for different types of
I
rocks.
just
So,
really want to go with that one rock.
Yeah. Okay, so we just finished on carbonates, right? So how can you tell if something is a carbonate? How can you tell if something is a carbonate, Ian?
By how it is composed.
How it's composed. So what do you mean by that?
Well,
What letters does it have in particular that make it a carbonate? So the 3 doesn't really matter, but the C and the O, what does the C stand for? Carbon, just carbon. And then what does the O stand for? Oxygen. So the C, it has to have carbon, and then also has to have the O, which is an oxygen.
What if it's just carbon, straight carbon?
basically elements.
There's that would just be an native element. If it's just carbon, then it's a native element.
It'd be a gas though, right?
It'd be a gas, yeah.
Does the CA stand for calcium?
Ca, yes, Ca. So yeah, capital C, lowercase a.
I figured out
Calcium.
what the Z
So halides, this is the next part where you're talking about. So halides, where can you find the halides on the periodic table? Where can you find those halides on the periodic table? Aiden,
right there in the blue, 17.
what group is it? Yeah, 17. Group 17, right here next to, does anyone remember what the group 18 is called? William, Bethy, or Ian, do you guys remember?
Probably says.
No, it actually doesn't say it on there. Does anyone remember what those are?
Actually, yeah, that is pretty. It has the colored labels.
Oh, I guess so. You just read the color.
Oh, it actually does say it on there.
I have horrible eyes, so.
Let's say, Johnny.
Dude, it's really
What is that group 18 called? They are the noble
Elements.
noble gases. Group 18. So all of those are noble gases.
No, Johnny, light blue.
Light blue.
Yeah, no, we don't like.
No, other light blue.
Oh,
Yeah, those are the halides.
pastel blue.
Yep, those are halides. So the ones we're talking about now are the halides. We could break down the entire periodic table. They are organized in a specific way for a specific reason, right? So these here in particular, one reason they're all in a group like this is for these reasons right here. Halides contain chlorine, fluorine, and bromine. So those are the actual, so F is chlorine, Cl is chlorine, Br is bromine, and then I is iodine, but they didn't put that up there for some reason. Number three here, it says common examples include salt, NaCl. So the chlorine represents the salt, the chlorine and salt. And then fluorite, that has calcium and 2 fluorine molecules in it. So those would be examples of halides.
Does per atomic number code use it?
Yeah, it does, but we're not worrying about that right now. So it does, but we're not worrying about it. Any questions about our halides? Any questions about the halides? William?
Like what makes which one of them like usable? Which ones like aren't usable? Which ones are? Like obviously would that make up all of them are useful?
Which one makes it useful?
No, like are they all used?
Oh yeah. Oh yeah. We use.
Or are they like one of them like that one that can only exist like in a couple of nanoseconds?
No, yeah. All of these you're going to see throughout nature. The only one that you're not, AT is highlighted right there. We're not using that one because it's radioactive.
Oh, that makes sense.
Right. And that's why we don't include it here within the minerals,
I didn't read
because it's not a mineral. It's still considered a halide, but it's not a mineral. That's why the AT is not listed, because it's radioactive. So it's not, it's technically not a mineral. Max, go for it. Yes, Aiden.
What is that one here?
The one cube
On the,
over there,
no, that one.
that's salt, and this is the fluoride.
That just looks like the cubes from the new forest.
Yeah.
It does.
All right, any questions with halides? This is all that I want you to know about them, by the way. Grady? Okay. So now oxides. Oxides. How can you tell just by looking at a chemical formula? How can you tell if something is an oxide? How can you tell? Dylan? How can we tell if something is an oxide?
Air, like a gas.
No? No. Bethy, how can we tell if something is an oxide?
Made up of oxygen and one or more metals.
Yeah, the answer is literally right there. Oxide minerals are made up of oxygen and one or more minerals. So in the equation, if it has oxygen listed with another metal,
It'll be oxygen plus air.
right, it's going to be an oxide, right? So this one right here, hematite. So it is in iron oxide. That's what this is right here, iron oxide. Fe stands for iron. Why is it Fe? It's because over in Europe, that's how they pronounce iron is. I can't remember the exact word for it off the top of my head. No, it's an actual word.
Oh,
Like the first two letters are Fe.
oh.
So instead of iron, it's not IR, because we actually have a different one for that as well. Limonite. Limonite is another type of iron oxide. Notice the only difference is this right here. This right here. The N and the H2O. The N, I don't really care if you know what that means, but for this part, it just contains a hydrogen and, or two hydrogens and one extra oxygen. Yeah, so it's part water. Exactly, it's part water. So that's the only difference between these two. Main thing you need to know, if it has a metal and an oxygen, it is an oxide. Yes, Aiden?
What does that?
The N stands for the number of water molecules there are.
So it have,
So it's an unknown variable.
oh, okay.
So there could be one
Yeah.
water molecule, there could be two, there could be three.
Okay.
Yeah, that's all that means. Yes, Ian?
So N basically stands for like unknown, known.
Right. Yep. So just like in math, if you were to use the distributive property here, N is the number of water molecules that you have. Well, I'm not quizzing you on that, but that's just what it means.
If you don't know how
Yeah.
many, say.
We'll talk about that in physical science next year. So you seventh graders, you have that to look forward to when we're doing chemistry stuff. Chemistry is one of my favorite types of science. Yeah, we will definitely blow stuff up. Brady?
What was the first title for Old Forest?
Halides. Halides. Ian?
If you knew what N was, would you put the number next to
Yes.
it?
Yes, you'd put the number in front of it. Yep.
So would it be capital or lowercase?
Probably.
The N is lowercase, the N is lowercase, so, because in math, this is where math and chemistry are so connected. The N always stands for the number of something, the number of something.
But if it was 2, it would.
Then it would be 2H2O. 2H2O, meaning there's 2 water molecules. If I were to draw that out on the board here, H2O.
And so that's what
That's-
means when there's a number in front of it.
Yeah.
Yeah, so if this is what your water molecule is going to look like, except this is a double bond, it just means that you have 2 water molecules now. You have 2 of them if there's a 2 in front of it, in front of the H2O. This right here, the little number that's like down below, it looks like it's an exponent, but it's down below. That just means there's 2 hydrogens, right? Oh, whoops, don't look at that. 2 hydrogens next to the oxygen. Mr. Doomer failed on that. I wasn't really thinking.
It would be hydrogen peroxide then if it was
Right.
2 oxygen.
Oh,
Yeah.
yeah, it would be.
Questions about oxides, Dylan?
No, we're talking about oxides, fluoride.
Okay, about fluoride.
How do they like make your toothpaste?
How do they make it?
Rock?
No,
They use
it's just a
charcoal.
different. So think about water, which is H2O versus H2O2. Water, which is H2O versus H2O2. You add 1 extra oxygen to H2O, and all of a sudden you have something that is a poisonous chemical if you ingest, called hydrogen peroxide. That's what you're doing to fluoride. If you have F, which is fluoride, once you start adding other things to it, it becomes a completely new element. So if you have 2 fluoride, then it's going to be different than just F. If it now has iron with the F, it's a completely new compound. It changes the structure, it changes if it's a solid or a liquid or a gas.
But what I'm saying is like, how, like, when you're brushing your teeth, you don't have like little bits of purple rocks in your toothpaste.
I know, and that's what I just explained. Water is completely different than
Mhm.
hydrogen peroxide. The only thing different about it is there's an extra oxygen. Same thing with fluoride. Fluoride and toothpaste, and even mouthwash are all very similar. What changes them? Their chemical makeup. That's it. The process of how they are constructed, it's really not that different, but it's just what their actual makeup is what's different. The reason you don't understand that is just because you've never studied chemistry. I wasn't trying to get into this, but all you need to know is for oxides, if it has iron and oxygen, it's an oxide. You don't need to know anything else. We'll talk about it more next year.
Do you think we could artificially bond stuff in the future?
Oh yeah, because we already have
Oh,
with certain things. Not, you can't do it with everything, but certain things, yes.
What if we are?
So sulfides, food. Food is what we artificially mess with all the time.
Oh, yeah, I guess so.
So sulfides,
Does that mean America thinks more fat?
that's why America's fat, is because we add stuff to our foods, add stuff to our chickens. We make them plumper.
Yeah. I watched this movie.
Okay, that's not what we're talking about though. Sulfides. Sulfide minerals contain sulfur and a metal, which in the name sulfide, so the sulf is represented by sulfur. It's really, all of these are really easy to remember because they pretty much tell you what it contains. The ides and everything means that it is a metal. It contains a metal, sulfide, sulfur, and metal. Oxide, oxygen, metal, right? Not too bad to actually remember when you break down the.
Mr. Doomer, can you send William down for just a moment, please?
Yes. So pyrite, what is pyrite? Well, pyrite contains iron and 2 sulfur molecules. Doesn't matter that there's a 2 there. No, it's just the only reason it is like that is because it has 1 iron, 2 sulfides, making it pyrite. The difference here, galena, which is lead and sulfur, there's only 1 sulfur, but lead is also there as well. So it is used, so pyrite, it's used in sulfuric acid, explosives, fertilizers, and insecticides. So I'm assuming that's for killing insects. Galena, so that's the lead and sulfur. It's used in auto batteries, solder, immunization, and then paint. So all those things, you don't want to eat or ingest sulfides. You do not want to ingest sulfides because it is not going to turn out good for you.
What's the last one before describing what it's used for?
No, I turned that off.
That's why lead paint works. They put it in.
Exactly, and there was lead, and they used to use lead a lot more, but they discovered how bad it is for you because look at what lead is in. Lead's also in car batteries. It's in all of these other things that are bad for you. Yep. No.
Yeah, that's why.
Your pencils used to have actual lead in them. That's why people always say, "Oh, can you have some of your pencil lead?" It's not actually pencil lead anymore. It's actually graphite. Yep. But it used to be lead at one time, so that's why people continue to say that. Yeah, Kayla.
So my neighbors used to shoot into our pond, and so there was lead in the pond.
Mhm.
And my uncle ate one of the fish, and my mom and dad told him over and over again not to
because-
lead poisoning.
Yep. Yep.
Okay now.
And that's one dangerous thing when you shoot anything that you're hunting for, a lot of the bullets are made of lead. So you have to be careful depending on what you're eating because the lead can get into the meat or the bloodstream of that animal. So you have to be really careful when you're hunting that you're making sure. Same thing with fish, right? So you just have to be careful when you're doing that because a lot of bullets are made of lead. Yes, Johnny.
What's that stuff that they quit using in insulation for houses?
That was,
Because I remember that was.
I know, I was trying to remember what asbestos. Yes, asbestos.
Asbestos is rude.
Very, very bad. They don't use that anymore. It used to be in schools. St. Helens High School used to have asbestos in it, and same thing with the old middle school.
A lot of old buildings.
A lot of old buildings.
My house is built in the 70s.
Yep.
And it has-
Yep. They used to use asbestos. Another it's not a sulfide, but it had some of those bad properties in it.
That's why you throw stuff in.
Right. Okay, so sulfides, then we get to sulfates. So we have the SULF, the sulf. That means it has sulfur in it again. That means it has sulfur in it. And then the ATES, the ATES, that means it has oxygen in it. Means it has oxygen in it. So sulfates are minerals that contain sulfur and oxygen. For example, SO4, combined with other elements. And it doesn't matter what other elements it is. It could be a gas, it could be a metal, it could be a non-metal. It doesn't really matter here. As long as it contains the actual sulfate, which is the SO4. So that's where it does matter. If it's SO4, that means it's a sulfate. So for example, some common sulfate minerals, gypsum, the guy mentioned it in the video, it's in drywall. We do not have drywall in this room. We have wood walls, but in most houses, most houses have drywall, right?
Probably insulation.
There's going to be insulation underneath, yes. But the plaster and the drywall, that is what the gypsum is. So at your houses, you probably have drywall. If you go inside the church building, you'll see what the drywall is. It kind of has that speckled feeling to it. That's actually the plaster. But that's one big thing that we use for sulfates is for walls, construction in general, paint, right? Paper, textiles. So sulfates are very, very important because of the bond that it creates with different things. Any questions about sulfates here? Brady?
I can like it because of the low to the high. Okay.
Now the online people get to see my feet.
Hello.
I like the toes, G.
Oh yeah, hi Talon.
Take off your shoes, like Talon. Don't you like his toes?
I'm gonna just turn the video off.
Uh-huh.
Bye-bye video.
But Talon wants to see your toes.
Tom wants to see the toes.
The toes.
Hi, Tom.
Oh, now I can't see.
The toes of
Oh, wait, there's Talon.
Talon, Aries, Ada, Calum, and
Blake.
Grace.
Grace.
And Blake.
You're here.
Like I'm really not here right
I'm
now.
like,
But he does.
Okay.
Okay, so that's our sulfates.
William.
What if, it's gonna work here?
Wait, no. Like,
I know.
Thank you.
Get your last 2 words.
I thought I saw that.
So after sulfates, we end up having something that is called our native elements. Our native elements. Who can give me an example of a native element? Bethy, go.
Polonium.
Polonium. Give me an. I'm gonna snake all the way around the room and ask all of you for a native element, starting with Johnny.
Oh, gold.
Gold. Oh, give me another native element.
Iron.
Iron. Perfect. Copper. Perfect. Diamond. Not diamond. Not diamond. Diamond is not an element. It's a compound. Ian.
Salt.
Salt. Nope. That's a compound. NaCl. That's 2 elements. So you could say Na, which is sodium.
Sodium.
Sodium. There you go. And then Courtney, you can just look up there. Silver. Yep. Aiden.
Boron.
Boron. All you gotta do is look up at the periodic table of elements, tell me a letter, and it's gonna be
Letters. That was the
Max.
PT.
PT. Which does anyone know what PT is?
Potassium.
Potassium. No, it is K. It is K. PT is plutonium. Dylan.
There's gold and VR.
No, fool's gold is a combination of gold and something else.
That's why I said VR.
So it's VR.
It's DS.
I don't know what VR is either. Bethy already asked you. Blake, give me one.
What's VR?
I don't know.
What's the very first one?
10 times.
H, hydrogen. How about hydrogen? Hydrogen's like the number one I think of.
Nitrogen.
We got nitrogen, oxygen, right? Carbon,
All the gases.
Right. Literally all of our gases. Potassium, which is K, Na, which is salt, right? Those right there, everything we just listed except for diamond, those are all examples of our native elements.
What is a
Max and Brady, go have a seat.
What's VR?
I don't know.
What is a ruby made of? Which color?
Go have a seat. You guys you'll get to be accustomed to your periodic tables when you work on your worksheet.
VR.
So go have a seat.
VR is red. I don't know why
There's a V up there though.
What does it mean, plaster?
Okay. So those are all of our native elements: copper, Cu, sulfur, S, rubidium, RH. We got, I'm not exactly sure, this one's probably copper as well. It could be something else, but those are all native elements. Those right there are all native elements, as long as it is a pure substance. So NaCl, which is salt, that is not a native element. That is a compound. NaCl, which is salt, was an example of, does anyone remember which one it was that we talked about? Go for it, Aiden. Halides. Halides, yep.
Which is basically the same word, which is halide.
Yep.
Isn't it like
Exactly.
sodium chloride?
Sodium chloride would also be an example, because sodium chloride is not necessarily salt in every scenario. Okay. Is this a slide that I already did? No. Okay. So a few questions I have for you. You might have seen them already. So get these written down. Get these questions written down. What 4 characteristics do all minerals have? Throughout this PowerPoint, I've given you all these answers. So what 4 characteristics do all minerals have? Who can tell me that one? What 4 characteristics do all these minerals have? Dylan?
That's why I put that in my answer. I was gonna say all of them are on Earth, but no.
That's not a characteristic though. Right, so what did we say in that video? What did the video say characteristics were? What did they say in the video characteristics were, Johnny?
They were classifications.
They're classifications. So thinking about playing cards, right? If you have a deck of playing cards, you have numbers that you could organize, right? So you could put all the 1s together, all the 2s together, all the 3s together. You have some that have letters on them. You got the king, the queen, the jack, the ace, right? You have some cards that are, you have all the cards that are divided by suits. You have clubs, you got diamonds, you got spades, you got hearts, right? That's another characteristic or classification of the card. Another one would be the color of the card, right? You have black cards, you have red cards, right? That would be another classification or characteristic of the cards. So what characteristics do minerals have? Kayla? Has to be natural. That's one. Johnny, give me one other.
They have a definite chemical composition.
They have a definite chemical composition. Aiden, give me another.
That was mine.
That was yours. Who can give me the last two? I'm not gonna put the answers up on the board if we don't get them as a class. Need someone different besides Kayla and Johnny. William?
Oxygen.
No, not oxygen. Brady?
Crystalline structure.
Crystalline structure. What else, Ian?
Oh,
Inorganic compound.
Inorganic. Whoop, that, I don't want, okay, well, there's your answer. So 90% of minerals contain this compound. That is oxygen, or
I
silicates.
thought we were number
Silicates.
3.
That is silicates.
Oxygen.
So 90% contain silicates, right? What make up silicates? Silicon and oxygen. Silicon and oxygen make up silicates. For number 3, what is the most abundant element in the Earth's crust? We all know that that's oxygen. We all know that's
We
oxygen.
talked about that yesterday.
We've talked about it yesterday. We've talked about it today. They talked about it in the video today. I'm just giving you guys another teaching tool. I'm saying the same things over and over again. And when I do that, that probably means a question or two like this will end up being on a quiz, on a final, on your homework.
I'm trying to implant it in your brain.
I'm planting the seeds.
How
You're messing
dare
with their
you?
brain.
Like branding?
Yeah.
You're implanting Dumerus.
Yep.
Dumerus.
All right, we good here?
No.
Yes.
No. Yeah.
No.
Few more seconds.
Wait, I need the last one. I can barely see.
I'm only doing this. I'm only on the second one.
So remember, you don't have to write every word that's up here. That's actually a worse way of writing notes. It's good when you're learning how to take notes, right? Is writing every single word up here because you're learning how. But the best way to do it is to summarize it in your own words. For number 1, what's a way we could write that question instead of writing out every single word? Brady?
4 characteristics minerals have.
Perfect. 4 characteristics minerals have. Perfect. Number 2, what could we say for that one, Johnny?
Most minerals contain this.
Yep, most minerals contain this compound. What about number 3? How could we shorten that one? Aiden?
Most abundant element in crust.
Yep,
That's fine.
most abundant or most common element in crust. But you're gonna know, for the most part, that you're talking about the Earth's crust,
Yeah.
right? Because we're not talking about pizza. So
Or pie.
we're not talking about pie,
Why not?
Why not? I want Thanksgiving.
because we talked about that last year.
We talked about pie last year.
We talked about food.
Wow. The earth is talking about
Brady pie is not only.
Actually,
All right, so now is the point. So on Friday,
Please don't make us write it.
you guys are going to be doing
That's where you-
this right here. You are going to be doing this assignment right here.
All the coloring.
It is worksheet. You don't need it right now, but this is what I'm going to give you guys time for on Friday. It is worksheet. Worksheet 122B. It's going to look like this. We have the entire periodic table that is written in black and white. What you'll do is rip that page out, and you'll also need the second page right behind it, which looks like this. It gives you hints for what to do for the coloring of your periodic table. I gave you a lab book. Yeah, I wrote your name in it.
Dude, we did a lab night not too long ago.
He wasn't here for it.
Oh.
So it has all the different clues here. It says color the symbols for the following elements bright blue, 35 and 80. 35 and 80. So for 35, we'd color in 35, which is bromine. Color that in bright blue. And number 80, right there, bright blue. Hey, they have the HG. Oh, it says just color the symbols. So you're coloring the symbol just like this. This is actually the key right here. So if you go home and you're like, oh, I forgot this, or I want to check if I'm right, this right here is exactly how you're going to be making your periodic table look. If it doesn't look like this when you turn it in, if it looks messy, because one thing I had in physical science a couple of years ago, one problem was I had a bunch of people just scribble all over it.
Yeah.
If it looks like garbage, I'm going to throw it in the garbage because that's where it belongs, right? It needs to look nice and neat, or else I'm not accepting it.
Who did you throw away? Like there was.
I don't know. There was someone I threw away.
Yeah.
Number 2 says color the symbols for the following elements. right? So it's just walking you through what to color everything. If you're coloring it nice and slow, taking your time, great, you're gonna do fine. But all the directions are right in here. That's what we will work on Friday.
But is there something, here's the element that we don't know what it is yet?
Yep.
Yes.
Yep.
How
Yes,
do
it
we know,
is.
like, if it's an element?
We don't. know.
Because we've only been able to see it for like a split second.
Can't Miriam like have the entire, doesn't she have the entire periodic table?
Why is
memorized?
like radio? Bro, I
Okay.
already wrote this.
So that's all we are working through today. That is all we are doing today. What do we do when we're done taking notes for an entire lesson? Kayla, you write a 3-sentence summary,
I
I said 3 to 4, 3 to 4 sentence summary for the lesson. So we have finished this lesson. So at the very bottom of your notes, just go ahead and draw a line as a divider and write down a summary in 3 to 4 sentences of the lesson. Do not copy anything word for word out of the notes. Do not copy anything word for word out of the book. This is your summary of the lesson in your own words, in your own words.
Your own work.
Yeah, I only said it like 10 times.
You said we could use the book.
You can use the book for reference, but you cannot just copy. That is, what is that called if you're copying someone else's work? Plagiarism. All right, that's it for today, y'all. Bye-bye.
Bye-bye.
Bye.